So if we want to do a problem using the quadratic formula, we want to solve for x here. Just like when we were solving by factoring, we need our equation to be equal to 0. That way we can actually find out what these a, b, and c values are in our quadratic formula. So the first thing we're going to do is subtract 11 on both sides. And notice how there's no like terms here, so I'm going to have to just kind of tack it on at the end, throw that minus 11 after the x. That way it's in our standard form trinomial. All right, so the next thing that we're going to do is actually figure out what a, b, and c are. So what's lovely is that it goes in order, and if you don't see a number, there's that imaginary one going on. So that means that a is going to be 1, b is equal to -10, and c is equal to -11. So make sure you notice the signs there. And now I'm going to go fill out my quadratic formula. So I'll show you this one all the way out. Negative b, when b is negative, we'll have that double negative action. Notice when I do b squared, I'm going to put that in parentheses. That's super important because we really want to make sure that we know negative times negative is going to be positive. So always use parentheses and then 2 times a in the denominator. So now I'm going to simplify. So we've filled it out. We now have what x is equal to. It's just really crazy to say x equals all of this. Like, that's not really helpful, right? So we want to actually simplify it down. So we've got that -10, which is really just +10, plus or minus, and you might be able to do this in one step, but I want to just show you doing all of this in the square root. -10 squared is +100, and then we have this -4 times 1 times -11 will be a plus, and then we got that 2 in the denominator. So now I'm just going to keep simplifying here. I'm going to do, just like in PEMDAS, we've got parentheses. This square root here is really behaving like a parentheses. That's why sometimes we say GEMDAS, if you've heard that one. That means grouping. So we're going to do this grouping action before we can combine anything else. Let's keep going. So I can do the square root of 144. That's a nice, lovely square root. So, or perfect square, so we're going to get a 10. And then we now have this weird looking thing. So we've got 10 plus or minus 12 over 2. This is 2 answers. So we can actually just break it up into the 2 different options, where x could be 10 plus 12, or maybe x is 10 minus 12. We're going to get 2 solutions, just like when we solved by square roots and when we solved by factoring, how we would often end up with 2 solutions with these problems. So now I'm just going to go through both of these options here, and we'll get x equals 11 or x equals -1. So both of these are our solutions, also known as our zeros. And notice how they're both integers. They're both nice, pretty, rational answers. So we have 2 rational solutions here. And the reason I'm saying this is because it's going to be important as we go to the second part of our lesson today. All right, so example 2, I want to solve with the quadratic formula. Again, I want to get this equal to 0, so I'm going to start by adding 6 to both sides. Now I'm equal to 0, and now I can pull my a, b, and c. So a is going to be 2, b is going to be 6, and c will be -7. So now I'm going to go through and fill out the quadratic formula, looking over here. All right, so I just plugged in all of those values for our quadratic formula here. So now I'm going to simplify. Just going to call that a -6 from our -b, plus or minus. And now we want to simplify the stuff inside of the square root. So I'm going to do this in 2 steps. If you wanted to do it in 1 step, that is totally fine. And we'll get the square root of 92 here. So this one's a little bit trickier than the last one because 92 isn't a perfect square. So we've got a little bit more spice. We got to do a little bit more work. So I'm going to do my factor tree for 92. So I get a 46, and then I'm going to keep dividing by 2 until I get to only prime numbers. So now I see all these prime numbers. I'm going to group them. So the 2's, there's a pair of those. But the 23 didn't have any partners. That's going to be stuck inside the square root. So I'm going to pull 1, 2 out, because when you have the pair, just 1 makes it out, and then the 23 is stuck inside. So then the last thing that we need to do here is notice that we can't really simplify the square root anymore because I just spent some time doing that, but what we can do is simplify the stuff outside of the square root. So if all 3 of these terms can divide by the same factor, then we actually get to simplify it down. So here I divided everything by 2 because all of those coefficients, all those terms could divide by 2. And that is how we finish this problem. So notice here we have the plus or minus. So even though it doesn't look like it, this is actually 2 solutions, and they are 2 irrational solutions because we have the square root, and that's not rational when you try to do the square root of 23. This is going to be some bananas looking number for these guys. Our last example here is going to have imaginary numbers. So I expect to see a negative under my square root because that's where imaginaries come from. Remember that the square root of -1 is I. So I'm going to start by getting this equal to 0, our classic first step. And then I'll have x squared minus 6x plus 10 equals 0. Fabulous. A, B, and C come next. So remember, if there's no number in front, it's assumed to be 1. So A equals 1, B is -6, C is 10. So I'm going to go ahead and fill out our quadratic formula. All right, the next thing that I'm going to do is simplify. So that -6, we'll just go ahead and call that a +6. Now I'm going to deal with the square root here. So I'll have 36 minus 40. And I'm noticing that that's going to give me a negative when I go to actually simplify that. So then we have the square root of -4 under this, in the square root. We got -4. So negative means imaginary. We know off the top of our heads that the square root of 4 would be 2, but if it's negative, that means that we'll end up with 6 plus or minus 2i. So we talked about this last class with our complex numbers. You could still break this down. I like to call it -1 and then the 2 and the 2. Those guys pull out to be a 2. This guy pulls out to be an I. So we have 6 plus or minus 2i. But again, we've got this problem where all 3 of those could divide by 2. So let's go ahead and divide them by 2. And the 2 in the bottom will just be a 1 in the denominator, which means we don't even need to write it. And so this is our solution set here. We have 2 solutions because there's that plus or minus. That means 3 plus I is an answer, 3 minus I is an answer. And they're imaginary, they're complex. So we get 2 imaginary solutions.